Let's continue this lecture and continue this result. So we show that L composition R is subset of R composition L. So for this we take a pair in L composition R. So choose a pair in L composition R. So suppose this pair belongs to AB, it belongs to L composition R. Now you apply the definition of composition. Then there exists an element C in S such that AC they are L related and CB they are R related. That's the definition of composition. So now let's apply that proposition. Okay, they are L related and they are R related. So thus there exist two pairs, one for L and second for R. There exist XY UV in S1 such that XY for L means that XA is equal to C left side and second is the YC which is equal to A. And here we have U and V, they are on right side, so UV is equal to B and BV is equal to C. Okay, let's write an element D. Let's define element D. Define D. We define this element D, which is equal to the product YCU. YCU. Okay, YCU in S. Then we can see that this AU, this is equal to what's this AU? A is YC. Okay, this A, where is A? A is YC here. Okay, it's YCU, so that's equal to D. So AU is equal to D. Now let's see DV, not DV, let's see yes, let's see DV now. DV, what's D? D is YCU V, YCUV. Okay, now this CU it's equal to B, this is equal to YBV, and BV is equal to C, this is YC, and that YC, this YC it's equal to A. So AU is D, okay, and DV is C, so that is, we have this thing, AU is D and DV is A. Okay, so this means that A and D they are R related because we have elements U and V for AD. Okay, they are R related and these elements are on the right hand side. AD belongs to R. अब मैं प्रूव करूंगा DB L में है, AD R में है, DB L में है, तो कंपोजिशन में क्या होगा? AB. Now let us see that this DB it is in L, the pair DB is in L. Now let's find this element yb. This should be equal to d. Then we should see xd, that should be equal to b. Yb, okay. What's yb? What's your b? B is equal to it's I think cu. B, value of b, it's a cu, okay. Value of b is cu, and this ycu, it's equal to d. And now let's find xd, okay. Let's see xd. Xd should be equal to b. Sorry, it's d here. Xd, it's xd, that's equal to x and d. What's d? D is ycu. D is yc, okay. This yc, it's equal to a. This is xau, but what's this xa? This xa is c, it's equal to cu, and cu is equal to b. So that's, we have this yb is equal to d and xd is equal to b. अब लेफ्ट साइड आपके एलिमेंट्स आ गए x और y for the pair a, d and b and d. So this implies the pair db, bd one and the same thing because they are symmetric relations. This db, they belong to elements are on the left hand side, they are in L. So therefore the pair AB, because AD is in R and DB is in L, so the pair AB must be in the composition R composition L. Thus this L composition R is subset of R composition L, and hence they are equal. क्योंकि हमने कहा कि हम एक ही पार्ट प्रूव करेंगे, the reverse inclusion follows our similar lines, and hence this L composition R is equal to R composition L. So they are equal. They are equal. And it also follows that therefore it follows that the join of L and R, this is equal to L composition R, because they commute. So which implies your D is actually the relation D, which is the join, is equal to L composition R. That's equal to L composition R. And we have the following inclusions actually. This H, it is subset of L because it is the intersection, and L is subset of which relation? It's subset of D because D is the composition, D is the join. So D it is subset of D, and D is subset of J, that you can see, and J is subset of the universal relation. This is the inclusion among these relations. अब इसी तरह से R के लिए भी होगा. H is subset of R, R is subset of D, D is subset of J relation, and J relation is subset of S cross S. And you verify that for groups, verify that they all are trivial. They are all actually universal relations on groups. H is equal to L is equal to R is equal to D is equal to J. They are equal to G cross G on a group G, on a group G. So you can easily do it because we have inverse in G. You can easily verify these things. They are all equal. And for a commutative semigroup, we have the following exercise that you can also easily verify. Because on commutative semigroup, L is same as R, left compatible is same as right compatible there. So L is same as R actually on a commutative semigroup. you should write and. Okay. So for a commutative semigroup, that's one more exercise. For a commutative semigroup, for a commutative semigroup, for a commutative semigroup S, show that these relations, H relation is same as L. Actually L and R are same, you need to verify just this, they are same actually, therefore their intersection, their intersection is same, because when they are same sets, so their intersection either L or R, so that means H is equal to L and R, and their join is also same, that's T your, and this T is equal to also G, but in general they are not equal to S cross S. So that's the end of this lecture. अब इसमें इंटरेस्टिंग क्यों है ये रिलेशन सेमी ग्रुप्स में? आपने देखा कि ग्रुप्स में सारे जी क्रॉस जी के बराबर हैं, ग्रुप्स में इनकी कोई इंपॉर्टेंस नहीं है, बट फॉर सेमी ग्रुप्स दे आर वेरी इंपॉर्टेंट. तो आप ये भी कह सकते हो, यू कैन आल्सो कैरेक्टराइज द सेमी ग्रुप्स एज फॉर विच दीज रिलेशंस आर इक्वल है. तो ये भी आप देख सकते हो वो कौन से सेमी ग्रुप्स होंगे जिनके लिए रिलेशंस इक्वल होंगे, या वो कौन से सेमी ग्रुप्स होंगे जिनके लिए ये सारे रिलेशंस यूनिवर्सल रिलेशन के बराबर आ जाए. ओके, एनी क्वेश्चन?